condensate pumps, steam traps, and PRVs and safety relief valves today. So, are you guys familiar with shell and tube heat exchangers?
Heat exchanger, yeah.
Okay. Basically what we're doing here is with the PRVs, we're knocking down the steam pressure from what would be like 60 psi down to about 12 psi.
What's your high side and your low side?
High side, low side, that's what a PRV does.
Did you need a laser pointer?
Sure. So here's our PRVs. I think they're a 1-inch PRV. So if we look at a PRV, of course it goes from a high inlet pressure to a low inlet pressure. Here we're coming through a electric control valve over to two other electric control valves that supply the steam to the heat exchanger based on the outgoing temperature that's required. Off of the heat exchanger, the shell and tube heat exchanger, we come down here to two Armstrong F&P steam traps, smoke thermostatic, that discharge into our condensate return system that returns the condensate back and forth. Up here is our SRV, which is set probably for about 10% over what our set pressure's at. Is that what it is? Yeah. 25 pounds. Yeah, so that's about right. So if these PRVs fail, then the SRV is going to open up.
Well, what I wanted to know is on the primary and the secondary.
Right here?
Yeah, the PRV and all of our other belts, the secondary is always twice the size. Because if it doesn't make up on the primary, the secondary will kick in with such a twice as much force.
Yeah, these weren't set up for a 1/3, 2/3 setup.
Oh, it's
That's what you're talking about. They're set up for just one pressure coming out. Both of them are set up that way.
Right, okay, and that's why they're looking inside.
Right.
So that there is no secondary or the primary.
Not that I'm aware of.
Okay.
I haven't looked through that paperwork to see how the engineer wanted it to be sized. So
Okay.
right now they're set up at the same incoming inlet pressure and the same out.
Okay.
Now, if we need to, I'll go back and look at that and just verify that for you if they need to be set up as a 1/3, 2/3 setup.
Okay.
But if we go now, we've gone through all the equipment. What can go wrong with the pressure reducing valve?
Well, the pressure reducing valve, if the pilot valve is the first thing that's going to go wrong. The pilot valve is going to go. That's the first thing.
Yeah, so there's two valves on this, right? We got a pilot valve and a main valve. So what usually happens with these PRVs is dirt.
Well, yeah.
And we got little restriction orifices underneath there that are pushing pressure up on the diaphragm,
Right.
and those can get clogged.
Right.
Usually on startups. And also on startups, if we don't drain the condensate out of the lines when we start the system back up again, we can get water hammer.
Oh, yeah.
When you open that up. And that water hammer right here in the bottom of these valves right here will cause the diaphragms to crack. So we got to make sure if we're going to shut down the system that we drain condensate.
It's draining out of the triple H?
Yeah, well, I think he's got some lines right here that are discharging into this low down.
The lower side is the high section of the triple H.
Yeah, so we need to get rid of that condensate out of there because when you shut the system down, steam in the pipes will condense.
Well, yeah.
And it turns back into water, and then if we turn it back on again,
Right.
it's going to hit that diaphragm on that valve, and boom, you got failure.
That's happened a couple times.
Yeah.
Yeah, and we had to run and buy a new action valve and have to put it in.
Yeah. So
We've been down that road.
yeah. So let's make sure we get the water out so we don't damage. We carry all the diaphragms here in Salt Lake City and all the parts for the pilots and the main valves, all the kits.
Okay.
So if you guys need any parts, we have those too. On the shell and tube heat exchangers, what can go wrong in the shell and tube heat exchanger? Again, water hammer is the main culprit, and corrosion. So you want to make sure that you inspect these tubes, periodically for scaling, and we call it fouling. Because once they start fouling up, that hole in that tube becomes thinner, and you don't get the same heat that you were getting when they were brand new. That's why we put a fouling factor on when we size them. So, and it's pretty small. So when they start fouling up and getting corroded, you want to change the bundles out. Also, if we have water in this line right here, again, the steam line, the steam is in the shell and water is in the tube, right? So if we're not getting rid of the condensate out of the steam line, and we hit it with a slug of water, it's going to hit that tube bundle, and the tube bundle is going to rupture, and you're going to have a failed tube bundle. So periodically, just check the bundle to make sure that everything's
Yeah, we
okay.
also check we do the steam trap. Because if they're not separating the steam with the condensate,
Yeah.
then they're going to blow through.
And that's where I was going to get. The next thing here is the steam trap. It's located underneath the heat exchanger. They've got some insulation over them. They discharge into our receiver here that's vented. So what can go wrong with the steam trap in F&T? We have a
Orifice is the first thing.
right. Well, we have an air vent in there.
Well, yeah.
One, and it's a bellows. So if we get a slug of water that hits on that bellows, it's going to rupture it, and it's going to fail closed usually, or open. They can fail either way. And then the next is the float.
Float, which is the F&T equivalent.
Yeah, because we have the orifice at the bottom of the steam trap with the valve and seat hooked into a float. It's kind of like a coil float. So as long as there's condensate coming to that steam trap, it's going to get rid of it, and that's what we want to do. We don't want any condensate backing up into this heat exchanger, because if we do, we're putting steam in there, again, water hammer.
If we listen to a stat, it should hiss off. And
Yeah.
if it's a straight hit, then you're actually going to blow through.
And that would be on the air vent. F&Ts are a little bit harder to test because they're a continuous drainer. So as long as there's condensate coming out of that orifice, it's going to drain it out.
But you can tell by actually at temperature.
Well, one thing you can tell on an F&T is the thermostatic air vent. If that has failed, you're going to hear that high volume of steam. Usually, if that air vent should be closed.
Right.
Okay, so when the air accumulates in the top of that trap, it cools and then it opens up the bellows and then lets the air out, non-condensables. And then when steam is in the trap, in the chamber, then it closes the air vent. Okay, so you can hear that on startup. You'll hear a large amount of air going through there, and then it should shut off. If it's failed and it's failed open, you're going to hear a really high velocity steam going through that air vent. You're also going to see it out in your vent line.
Oh yeah, true, yeah.
That's a telltale sign of a steam trap. A lot of flash coming off of this vent line. So we got the PRVs letting down the pressure to our control valves. It's going to our shell and tube heat exchangers that discharge into our steam traps that now go into this vented receiver tank. So this thing should be kicking on once in a while. It's got a mechanical alternator on it, so it's switching the pumps back and forth.
So it's
it
not
gets clear.
high and low, but it actually like alternates.
It alternates, yes.
Okay.
The pumps, if we do have a blowing by steam trap, which is blowing by steam into here, these seals are not rated for that high temperature, so usually they don't last very long if you got a steam trap blown by. So you might have to possibly, replace these seals. And that's really the only maintenance that you would have to do on a condensate pump. Electric condensate pump would be the mechanical sealing. So, you guys have any questions?
I have one earlier on the system pop up, but they were gonna ask about it.
Yeah.
If the hammer had to go up, they popped off, that hammer's gonna be too long to let out.
Sure looks like it.
Steam, coming into that pipe, it's gotta be turned it away so it's really damp out. The little hose also have a pipe on it to drain. The condensate.
Yeah, there's right here. Yeah, it looks to me like it's pretty close quarters.
Yeah.
Yeah, and then this is the drip pan elbow that comes out of the vent right here.
I just go real quick, you know, we got like 3 quarters one there, going back in.
Going down here,
Yeah.
down into your blowdown. Well, that's what's, is that the line size off of the drip pan?
That probably goes into
Yeah,
the.
that's the size right here. Coming off the drip, so. That's just to drain that drip, when that valve goes off, when it, say for some reason, you know, it overpressurizes the system and the relief valve pops off, that there's going to be this flash steam or the steam in this line, this vent line, that's, yeah, so we need to drain, when it condenses, drain the water off.
Yeah, I understand. It popped off one time, it's something I could think of, right off the back, one up, and there was steam all in here. They were pushing the shutter off, I think, over there at the pump, from what I understand, and everything was wet in here. But to get leak caught it in time, I put it down for a little while. But that was tied, it was taped on, the handle was taped on. So I'm not sure that it would have been run.
Yeah, you want to make sure that on installation, some of that stuff should have been taken apart if it wasn't, it should have been. But you want to make sure when you operate these PRVs that you don't operate them too close to the set pressure, because that valve will sit in there and shatter, wear out. So looks like it's set pretty good right now. What made it go off? Does anybody know?
The pump head went off. It went out the pump, but I guess that went back filled and it popped.
The handle was taped on, so
That's
That's for circulating water.
Yeah, this is steam.
well, this was the only thing, because like I was off that day, from what I understood, that was the only pump that they could find, was the pumps were off. That's some other that, I don't know.
Yeah, this thing is set for 25 PSI. So the only way this thing is going to pop off is if these PRVs aren't working
If the head
right.
pressure went up past 20.
These would have to, fail.
Or one of these valves have to shut too fast.
this top one.
Yeah.
Well, maybe
Electronic
yeah.
valve fails too fast, that's what builds pressure instead of that.
One of my farmers opened it up and it just released some of the pressure off it. By then there was an electrician. I could swear he said to reset that over there. I don't know how. And then somebody said he must have meant to shut the pump off or something. But I know this was going off. I don't know, I can't say it was this exact one, maybe it was the hot water tank. But there was enough steam in here, and everything was soaking wet that it seemed like it was
Well, that would be the case, but like Kevin was saying here on these valves right here, these should be a slow-acting ball valve. And I didn't supply the ball valve, so I don't know what was supplied, but if these are fast-acting, that will be slammed shut. There's going to be a pressure spike right in here that could cause that relief valve to pop open. So, recommendation would be to check and see what these are. And these valves right here to make sure they're a slow acting. And if they are fast acting, you might want to,
Maybe actually slow them down.
yeah, see if you can slow them down. Because that could be why that popped off.
Okay.
Other than that, the system looks pretty good.
Now, again, we have air breathers on them.
Air vents, yeah.
Air vents.
Yep. You got some getting rid of the air and the non-condensable
Which
that are
I'm
building
glad
up.
to see that. I'm glad to see that.
That's good. There's also vacuum breakers integral with the steam traps down here.
Yeah.
So when these valves modulate back and you get a vacuum in here, you wouldn't be able to drain it still. So that
Sure.
breaks the vacuum. So you get gravity drainage back into your receiver tank. So everything looks good.
Good.
You guys have any questions for me?
Not for me, but
He's alternating back and forth. This one is off, this one's on,
and
this
the
one's off.
trip.
So, anytime you guys need any help with anything in your steam system or condensate return system, give me a call. I've been doing it for 27 years, so I know a little bit about it.
Now, are these the only heat exchangers we have in here?
This is Kevin with PAT Mechanical. We're going to be talking about the shut-off valve makeup water to the cooling that's outside. There is a 2-inch valve right here. This is the valve that you want to shut off in the wintertime when you do your draining. Okay, and then up here in the tunnel, up the stairs, you'll shut that valve off out there. Come in here and you can open up this ball valve right here and it'll drain it down into the sump, and that will drain all the makeup water that goes from the cooling tower back to here, so we don't have any freezing under the ground during the wintertime. And that's all I've got to show you on your makeup water.
So you close it off, open this one, drain the tower?
Yep.